Hi everyone, it's Elliot from TutorialEdge.net, and in this tutorial we're going to be looking at the basics of working with GraphQL in Go. Now this was the most popular topic for doing a video this weekend based on the poll that I posted on Thursday, and I'd just like to say thanks to everyone that voted in that, and thanks to everyone for their great suggestions. Now if you do have suggestions for content that you would like to see in the future, then please let me know in the comments section down below. And as always, the full text version of this tutorial can be found on my website, and I'll also leave a link to that in the description below. So let's dive in. Now what are we going to cover in this tutorial? Well, we're going to cover the basic theory behind GraphQL. We're then going to look at how you can create a simple GraphQL app in Go, and then we're also going to look at how you can query GraphQL in Go and get responses back from the server. So let's dive into the theory. Now let's have a look at the traditional approach that most developers tend to follow. Now imagine you were developing a front-end application that was written in something like React or Vue or Angular. Now the traditional approach would be to hit a number of API endpoints to retrieve the information that you want to render within this front-end client. Now this approach is great and it's one of my favourite approaches to developing applications. However, for more complex applications, this can sometimes end up with multiple HTTP requests just to render simple components. Now let's imagine that I'm a developer working on an application that scales to thousands if not millions of users per day. If I'm just trying to render a simple component that features a tutorial title, and I need to hit the tutorial endpoint, which returns a response like this, then suddenly I'm getting a lot of redundant information. And this can be very, very expensive in terms of the network costs associated with it when it starts to scale to thousands if not millions of requests. Now this is where GraphQL comes in to save the day. With GraphQL, I can define a query that contains only the fields that I want or need for my particular component. This query would then be sent to the GraphQL server, and the GraphQL server would then do the job of resolving each of these fields to the various API endpoints in order to collate the data into one response that is then sent back to the client. So one of the key points to note here is that the client is only making one HTTP request to the GraphQL server. The GraphQL server itself is then doing subsequent HTTP requests, but these are far quicker and more efficient, as the GraphQL server tends to live in the same underlying infrastructure as the rest of your APIs. Now, one important thing to note is that GraphQL is not a query language like traditional SQL. It is an abstraction that sits in front of APIs and is not tied to any specific database or storage engine. Now, this is actually really cool, as it means we can stand up GraphQL servers that interact with existing services, and then we can build other components or clients around this new GraphQL server instead of having to worry about modifying existing REST APIs. Cool, so with the basic theory out of the way, let's dive into Visual Studio Code and start creating a really simple GraphQL application in Go. Cool, so as you can see here, I've got an incredibly simple main.go file that just simply prints out GraphQL tutorial. Now, let's start to modify this so that we can build up a simple GraphQL application. Now I'm going to start off by importing the GraphQL package that we're going to be using. And this is going to be github.com/GraphQL-go/GraphQL. Now within the main function, we're going to start off by defining the fields and how they resolve. So I'm going to start off with fields is equal to GraphQL.fields. And the first one we're going to do is the hello field, and this is going to be GraphQL.field, like so. And we're going to say this type is a GraphQL string, and then we're going to define the resolver function. So func p GraphQL.resolve params, and this is going to return an interface or an error. Now, it's in here that we typically do the subsequent HTTP request to retrieve the information that we then resolve for this particular field. But for now, we're going to keep it nice and simple and just return world, if I can spell it right. And there's no error, so we'll just return nil like so. Now, let's add the commas. So just in here, and then just below where we've defined this fields object, we're then going to define root query is equal to GraphQL.Object config. This will be a name, which will be root query. And then we're going to pass in the fields. So fields, like so. Next, we're going to define the schema config. And I'll go into this in more information in just a second. But for now, GraphQL.schema config. Pass in the query. And that's going to be GraphQL.new object root query. Like so. And then finally, schema or error is equal to a new GraphQL schema. So GraphQL.new schema config. And then as we're getting an error, we want to do if error does not equal null, log.fatal if failed to create new GraphQL schema, and then we're going to throw out the error. Like so. Cool, so let's break down what I've done here in a little bit more detail. Now, effectively, these 3 lines of code set up the schema for our GraphQL application. Now, within this schema, we define the query type, and this query type acts as the main entry point for every GraphQL query coming into our GraphQL application here. Now, we've then mapped this to a new GraphQL object, which is called root query. And within this, we pass in the fields that we want to resolve, which has hello and the resolver function like so. Cool, so now that we have the basic schema up and running, let's have a look at how we can then query against this schema. Now, I'm going to start off by defining the query itself, which using backticks, we're just going to define curly braces and then hello. Now, this hello field is going to map up to this hello field within our schema, and then it will resolve to this function here. So we should see that whenever we pass in this query to our GraphQL schema here, it will return the data world back. Now let's see if that is the case. So the first thing we're going to do, params equal to GraphQL.params. We're going to pass in the schema that we're trying to query against, and the request string, which will be the query. Then we want to do r equals GraphQL.do, basically execute our query. And then if length of errors is greater than 0, we want to log.fatal if failed to execute GraphQL operation errors, and we want to use %+v to print out the errors, so r.errors, like so. Cool. Now, if there are no errors, then we want to print out the JSON, so r.json or error, which we're going to leave blank, is equal to json.marshal, the response, and then we want to print this out, so fmt.printf, and %s/n, oops, wrap these in quotes, and then pass in r.json like so. Cool. Fix that one wee typo there. And as we're importing or using the JSON package, ensure that encoding JSON has also been added to the list of imports at the top of your application. Now, with everything in place, let's test to see if this runs. So go, run, main.go. And as you can see, our query has been successfully hit against our GraphQL service, and the field has resolved successfully to return the data world. Awesome. So now that we have got a really simple GraphQL server up and running, and we're able to query against it, let's take it a step further and build a more complex example. Now, we're going to be creating a GraphQL server that returns a series of in-memory tutorials, as well as their author and any comments made on those particular tutorials. So let's start off by going up to the top of our application and defining a couple of structs that will represent a tutorial, an author, and a comment. So type tutorial will be a struct. This will have a title, string, we'll give it an ID, which will be an int, and an author, which will be type author, and comments, which will be an array or slice of comment. Next, let's do type author, struct, we'll give it a name, which will be string, and tutorials, which will be a slice of type int, and then finally let's do type comment, which will be a struct, which will just have a body of type string. Now the next thing I want to do is to create a simple private function called populate, which is going to return a slice of tutorials, tutorial, like so. So in this I'm going to define an author, which will equal at author, can't type, give a name, Elliot Forbes, and tutorials, we're going to map int 1, like so. Next, let's define a simple tutorial, so tutorial is equal to tutorial, and give it an ID of 1, comma at the end, give it a title of Go GraphQL tutorial, give it an author, which will be a pointer to an author, and comments. So comment, and the body is going to be first comment. Cool. Next, we're going to do var tutorials, tutorials, like so, tutorial, and then tutorials equals append, tutorials, tutorial. Nice wee tongue twister. And then we're going to return tutorials. Cool. And I'm just going to fix the ID here. Cool. So with this in place, let's start off by creating a new object in GraphQL using the GraphQL.New Object function that we used before. We're going to define 3 types using GraphQL's strict typing. These will match up with the 3 structs that we've already defined. Now, our comment struct is arguably our simplest, as it just contains a body, so we can represent this as a comment type fairly easily, like so. So within our main function, we're going to do var comment type equals GraphQL.New Object, and then GraphQL.Object config, which will have a name, comment, and then the fields we're going to define, fields are equal to GraphQL Fields, type GraphQL.string. Oops, sorry. So the fields are going to equal body, I should say, missed a step, GraphQL.field, and this field is going to be type GraphQL.string. It's better. Then we add the commas, like so, and the comma at the end there as well. Cool. Next we'll tackle the author struct and define that as a new GraphQL object as well. So var author type equals GraphQL.New Object, GraphQL.Object config, name is equal to author, and then the fields are going to equal GraphQL.fields, and then we're going to have the name, which will be GraphQL.field. Again, it's going to be type string, GraphQL.string, and then we're going to do tutorials like so, which is going to be another GraphQL field, and this is going to be type GraphQL.new list, GraphQL.int, like so. Cool. And then finally we want to define the tutorial type. So just below where we've done the author type, let's do the following. So var tutorial type equals GraphQL.New Object once again, and GraphQL.Object config. The name is going to be tutorial for this one. And then we're going to have a number of fields here. So GraphQL.Fields. First one is going to be ID. GraphQL.Field. And this is going to be type GraphQL.int. Capitalize the int. Next we're going to have the title. So title. Another GraphQL.Field. This is going to be type GraphQL.String. And then author, which is the first more complex one, is going to be GraphQL.Field. And then the type is going to be author type, which we've defined above. And then comments just below this is going to be another GraphQL field. And this is going to be type GraphQL.New List and comment type. Awesome. And let's just close off these commas. Perfect. So now that we've defined our type system, let's set about updating our schema to reflect these new types. We'll define two distinct fields. The first will be our tutorial field, which will allow us to retrieve individual tutorials based on an ID passed into the query. And the second will be a list field, which will allow us to retrieve the full array of tutorials that we have defined in memory. So for this, we're going to overwrite the existing fields that we have, and I'm going to change hello to tutorial. I'm going to change the type to tutorial type. And I'm going to add a description. So get tutorial by ID. I'm going to pass in the args, which are the arguments passed into this field. And GraphQL.Field config argument. This is going to be an ID at GraphQL.Argument config. And then this type for this ID is going to be GraphQL.Int, like so. Now, just below this, we want to define the resolver function. So I'm going to want to do the following. So ID or OK is equal to p.args ID. So this is basically trying to retrieve the ID from the map of arguments passed into this query. And then I'm going to typecast this to int. And I'm going to say OK. If this is part of that argument, then I'm going to do the following. So for underscore, to ignore the index, tutorial in range tutorials, I want to do if int tutorial.id is equal to the ID passed into this query, then I want to return that tutorial or nil, like so. Awesome. And then I want to do nil and nil for now. So just quickly, we're trying to iterate over this range of tutorials, which is currently undefined. So I want to do the following. So tutorials, just at the top of my main function, I want to do tutorials is equal to our populate function. So that'll populate this list of tutorials with the tutorials that we've defined here. Cool. Now the next field that we said we were going to define is the list field. So I'm going to come down here and I'm going to do the following. So make sure it's in line, and it is. And list is going to be at GraphQL.Field. The type for this is going to be GraphQL.New List, and this is going to pass in tutorial type. And then the description is get full tutorial list. Oops. And then we're going to define the resolver function. So resolve equal func p GraphQL dot resolve params, and this is again going to return an interface or an error. Now within this, we're not doing any filtering, we're just returning the list of populated tutorials, like so. Awesome. So now that we've updated our GraphQL schema and the field list, let's try hitting some of these fields now. So I'm going to hit the list field first of all, and I want to retrieve the ID and the title for every tutorial within my tutorial list. Now, opening up the terminal, I'll just make this slightly bigger. I'm going to do go run main.go, and as you can see here, hitting this list field with this particular query has returned an array list of all of the tutorials that we have currently populated, and it's only returned the ID and the title for those tutorials, which is perfect. Cool, so the second field that we defined was the tutorial field that featured a couple of arguments. So let's try and update the query and test to see whether this works within our query now. So instead of list, I'm going to do tutorial, and then I'm going to pass in an ID of 1. I'm going to remove this field here because we don't need it. And then I'm also going to query the author of this tutorial with the name and the tutorials that that author has also written. Now, once again, go run main.go. And as you can see here, it successfully returned the tutorial matching the ID of 1. And it's passed me back the author with my name and the IDs of all the tutorials that I've written, as well as the title of this tutorial. So that's all we're going to cover in this tutorial. Now in this tutorial we've covered quite a lot of ground, such as the theory behind GraphQL and why you should use it. We've also covered the basic Hello World example from the GraphQL package, and then we've looked at how we could extend this to expose a number of tutorials or a number of fields that would query against an in-memory database. Now in the next tutorial we're going to be looking at GraphQL mutations, and we're also going to be looking at how we can expose this GraphQL application as an endpoint so that other clients can interface with it and retrieve the data that they wish. Now, if you enjoyed this tutorial, then please leave a like in the video, and let me know in the comment section down below what else you would like to see. Now, as always, thanks for watching, and I'll see you in the next video. Cheers!